and greenhouses. And first of all, we have, as I already said, the database that is developed. Then we go to the growers and give, based on their first approximation, if the grower wants, we can go and give more information and also take the control of its farm, of its greenhouse or orchard on the irrigation. So in the first page of the project, in the visitor pages, we can see the database that is there available. I will not give much time to this presentation because I would like to focus mainly on the online irrigation scheduling. In this page, that is a database, the visitor can go and see the water needs that have found from different publications or experiments that have been done, or the data that we found in on the world in the literature for different orchard trees, for example, for citrus here, for different varieties and different rootstocks or soil types, irrigation systems, and different climate zones. And we can show these data by figures, and the visitor can compare different irrigation strategies or irrigation techniques and how these affect the water consumption and the production of the different crops. And of course can add his own data and compare his own production and water consumption with the data that we have in the literature, as shown here with the red column, for example, and see how efficient is the irrigation management that he is doing. And of course, there is also a profit analysis about that takes into account the water that is consumed and the yield that we obtain, if we know, of course, the cost of per cubic meter of water that is used, and also the selling price of the products. And we can then compare the different cases found in the literature with our own case. Similar data have been found for greenhouse crops. For example, here are data for a cucumber crop with different varieties, hydroponic crop, and in different substrates. Of course, here the visitor can change all these data and obtain different graphs here and see the different data for different crops, of course, and soil systems that we have collected, and compare with his own case again. How efficient is his own case with the different data that we have found in the literature. We have seen, for example, here that for tomato, the yield, of course, is almost linearly correlated with the water requirement that we have found in the literature. And we have, of course, a higher value here. That means that even if we increase more the water that we consume, the production cannot be more increased again. We have data from different cases around the world, and these can be shown also in the map. The visitor can see from where these data come from. We have two greenhouses that take part as users of the greenhouse, in this case in Greece. There are two locations in central Greece. For example, we have a greenhouse that is half an hectare, cucumber, cultivated greenhouse. And we studied this case because we had seen that although the production increased every year, as is shown by data that the grower had, the water consumption was almost constant. So the water productivity was not, let's say, increased because he saved water, but because he just increased the production. And we wanted to see if we can keep at least the same production by decreasing the water that is consumed. As usually, the growers have a practice that is, let's say, a practice that gives good production, but they don't want to change this and risk any loss of production. So they apply usually more water than is needed. And since we talk about hydroponic crops, they apply more fertilizers than needed. Just to give an indicative value, we need about 25,000 euro per half hectare of cucumber for the fertilizers only per year. So it's 25,000 euros per year for this greenhouse, for example. If we save even 10% of these fertilizers, then it's a good profit, in fact, for the crop. So we installed there some sensors, in fact temperature and humidity sensor for the air temperature and humidity, solar radiation sensor, and we also installed two irrigation and drainage meters for measuring the water that is applied and the water that is drained by the crop. And we developed also online web-based software where all these data that have been installed, the sensors that have been installed in the greenhouse, give this data in a web page so that also the growers can see these values in real time, but also can see what happened during the last days or during a certain period. He can take, he can compare the data that he has, for example, to see how much is the temperature inside the greenhouse and the humidity during the previous period. And the significant is that he can compare his data with the data that other growers that participate in the system can also have. So it's shared practices, sharing data in order everybody to gain. It's a win-win situation for everybody that participates, since he can see what is the neighbor doing, and if he then practice of the neighbor is better than his own practice. So taking into account the data that we take from the greenhouse, we show to the grower some first figure, for example, how much is the drainage water that he has and the consumption, as is shown here in this slide. And here is a real good case where the drainage, for example, is about 33%. But when we started this application to the greenhouse that I presented you just now, we had seen drainage rates of about 70 or 80%. That means 70 or 80% of the nutrient solution that was given to the crop drains outside of the greenhouse. And if the system is open, then this drainage is lost. And it's not loss of water and nutrients, it's loss of money for the grower, and also its big effect to the environment. So by applying this system, that little by little the grower was consulting, we improved this situation, and we have seen that the grower now obtains drainage rates that are set for his greenhouse. So this was the first step to show to the grower what happens, and then to give him also some other indicators how is his crop performing and if his practice is good or not, and what he has to do in order to improve his practice. We give some calculations and some suggestions that he has to make, changes to make in his system in order to improve the irrigation and fertilizers use efficiency. Here, for example, is the actual water that he gave, the actual amount of nutrient solution, and this was the optimal one. That we can see now that he is very close to this optimal cheat. This is the daily transpiration that is estimated by our model, and this is the drainage that he obtains every time. So we give him an indication what he is doing and how to improve the situation. And if he wants, for example, to see what happened in the last 7 days, he can see a figure like this, where the blue, for example, is actual daily irrigation that he was giving. The green one, for example, here is what he had to give, in fact, as optimal. And the line is the solar radiation that we can see that is correlated also with the optimal irrigation that we have. Then if his grower wants more, we can give him a time schedule for the next day. That is every night at midnight we send him an email and say when exactly he has to irrigate the next day based on weather forecast that we take from the service or worker service. So he can apply this time schedule for the next day in order to obtain the best irrigation and water use efficiency that he could have. Of course, he can do that manually, but also we can install an extra machine to his greenhouse and apply this schedule in real time and take, in fact, control of his irrigation system in the greenhouse based on the measurements that we have in real time and the model that we have developed for the estimation of water needs. That I just wanted to add here that this model is automatically calibrated for each greenhouse and for each crop that we want to test and to want to operate. So with this I would like to finish and thank you for your time and for your attention.
Thank you very much, Nikos. It was a very interesting presentation, and I think that you also have to add that